Okay, so this is an example problem on linear expansion. So you are asked to build a steel bridge where the frame pieces are 150 meters long at 20 degrees Celsius. The bridge is in southern Illinois, so that's where we're going to see temperatures between negative 25 degrees and Celsius and a positive 45 degrees Celsius. How much will the bridge frame contract in these temperature extremes? So what's that difference of length of the bridge frame in these temperature extremes so that you can appropriately use expansion joints? All right, so we know from, if we look up, that steel is its own material, and it's going to have a coefficient of linear expansion and a coefficient of volume expansion. And so we want to think about, what does this one need? Well, we're going to talk about how the length of that bridge is going to be changing, and so this is a length expansion example. And so the alpha, the coefficient of length expansion for steel, is equal to 12 times 10 to the minus 6th per degree Celsius, or degrees Celsius to the minus 1. All right? We're given that the length of the steel, length knot, is 150 meters at a temperature knot, or beginning temperature, of 20 degrees Celsius. So let's first look at what happens to the steel when I increase the temperature to 45 degrees Celsius. This is a change in temperature of 45 minus 20, or 25 degrees Celsius is my change in temperature. What do I expect? Well, I know when things are heated up that I expect them to get longer, and so I'm going to expect my final answer is going to be larger than 150 degrees. So using our relationship for linear expansion, we have that the new length is equal to L naught times 1 plus alpha delta T. So what will my new length be? We have 150 times 1 plus 12 e to the minus 6th times 25. And again, what's important is that we're using our change in temperature. It's a change in temperature that causes the expansion. And we get our new length of 150.045 meters. So we get an expansion of 4.5 centimeters. Okay? Expands by 4.5 times 10 to the minus 2. Right? 4.5 centimeters. Okay. What about on the other side of things? What happens when I decrease my temperature to minus, what is my number? Minus 25 degrees Celsius. Okay? When I decrease my temperature to minus 25 degrees Celsius, my change in temperature is down minus 25 minus the original 20, and I get a minus 45 degree change. And I do the same thing. So my length, my new length, is going to equal L naught times 1 plus alpha delta T. Same relationship. So I have 150 times 1 plus 12 e to the minus 6 times minus 45. Make sure you're being attentive that this is a temperature drop, so we need that negative. And I get a new length of 149.919 meters. So I contract the steel, that's a contraction, by 8.1 centimeters. Okay, so it was 50. I went down to 149.919, so that's 8.1 centimeters. So I decrease by up to 8.1 centimeters. I have an expansion by up to 4.5 centimeters. And so I need to be able to accommodate a range of 12.6 centimeters. So that's how much of a range I need to be able to accommodate. All right, so just using our linear expansion, recognizing we're dealing with linear expansion and using the relationships that we have to figure out our solution. Good job.